Hello. This is the genuinely approachable Sudoku for the 13th of February 2024. Despite the name, this is for 13th of February. It is Valentine's Paris by Philip Newman, and you can see here there's a very clear theme of Valentine's Day. So yeah, let's just get right into the rules. Normal Sudoku rules apply. So place the digits 1 to 9 in every row, every column, and every 3x3 box. Digits in cages cannot repeat and must sum to the total given. So digits in cages cannot repeat, meaning that those two digits can't be the same. Even though by regular Sudoku they could, they are in the same cage, they cannot. Also, those three digits have to add up to 12 because the corner says 12. Those two digits sum to 13, those three digits sum to 10, and so on for every cage in here. Next, we have consecutive pairs. Digits in cells separated by a pink line, which are, these lines over here, must be consecutive, meaning have a difference of 1. So, for example, those digits are consecutive, which means they could be something like that, or like that, or so on and so forth. Other pairs of digits may also be consecutive, so there's no negative constraint, meaning those could be consecutive if you want them to be. And those are all the rules. So with that, let us get started. We can start with the easier cages first. The 4 has to be made of 1 and 3. The 16 has to be made of 7 and 9. The 17 has to be made of 8 and 9. And the 3 must be made of 1 or 2. And I can do stuff with this 1-2 pair here because that digit has to be consecutive to either 1 or 2. But it can't be a 1 here because then both of those cells would have to be 2. So that has to be 2, which is consecutive to 3 because it can't be next to 1. 1 is up here. And 1 here means that has to be 2. This cage means that has to be 3 to make 5. And that digit has to be either 2 or 4. 2 or 4. Because it has to be consecutive to 3. Right, this 3 here means those digits sum to 5, because 8 minus 3 is 5, therefore those digits cannot be 2, 3 anymore, it has to be 1, 4. This digit could still be a lot of things, so I think it could be, well, if it was a 1, that would have to be a 2. If it was a 4, that's either a 3 or 5, but because of the 3 here, this can't be 3, so that's 5 if this was 4. So we also have 2 options for that. Okay. What else do we have? I mean, we have some pretty decent looking cages here. Yeah, this 7 cage has to be a 1, 2, 4 triple. And so those two just have to be consecutive. Oh, never mind, sorry, this 3 resolves this pair. So that's 1, that's 3. 1 needs to be next to 2. 3 needs to be next to 2 or 4, which gives us another pair over here. Awesome. This digit, if it's a 1, it has to be next to 2. If it's 4, it needs to be next to 3 or 5, and there's no restriction this time, I think. Although 5 here means those sum to 4, which has to be 1 and 3. I don't know. Okay, I see. This can't be 4. If it was 4, those digits sum to 5. But because of the 4, it can't be 1, 4 here again, and it can't be 2, 3 because of the 2 here. So this cannot be 4, that has to be 2. Those digits therefore sum to 7. Could be 3, 4, or 1, 6. But it can't be 1, 6, because if it were 1, 6, where does 1 go? 1 can't go here by this one. 1 here would place 2 here, which breaks. So 1 can't be any of those cells, so this must be 3, 4. This cell therefore can't be a 3 because this would have to be 2 or 4, but 2 and 4 are already in the box with it. So this cannot be 3, that has to be 4. That's 3. 4 needs to be next to 5 because it can't be next to 3. Cool. 18 with a 5 here means those sum to 13. Not sure. We know that has 4 by the 2 over here. So those digits sum to 8 without using 2, 6 or 3, 5. They have to therefore be 1, 7. So that now can't be 7, that has to be 9, that is 7. This 1 means that's 4, that's 1, so that's 2. Okay, that makes a lot more sense. I didn't see the 1 see that cell. This 1 also resolves this 1 4 pair, which means this must now be a 2. Those digits have to be 5, 6, and 8 to complete the box. Those can't be 5, so 5 goes here. This forms a 6, 8 pair. Therefore, this has to be 2 or 4 to make 10, but it can't be 2, so that's 4, which must be accompanied by 6. That digit is 8, which needs to be accompanied by 5. All those digits are 7 and 9, but I didn't actually see this cage. That's 16, which is 7 and 9. The 1, 7 here would mean that digit can't be 7. That's 9, that's 7. Right, those 3 digits, none of them can be 1s by the ones in the rows. Therefore, the minimum we could have in those 3 digits are 2, 3, and 4, which do add up to just 9. So that means that they have to be 2, 3, and 4. That cell can be 3 or 4, so that's 2. This cell can be 4, so that's 3, therefore that's 4. These 2 digits must now sum to 7 to make 9, but can't be 3, 4, or 2, 5, so they have to be 1, 6. That means that's not 1, that must be 7, that must be 1. This digit can't be 1 either, because that will force 2 here, which breaks, so that's 6, that's 1. This digit is consecutive to 6, and it's either 7 or 5, but can't be 7, so it must be 5. Those digits now sum to 7, so we need 3 to make 10. Those digits are just 6 and 8, which we can resolve. This digit is consecutive to 7, which has to be 6 or 8, which we can't resolve at all. But I do tell you that, yes, because of the 5 here, those digits sum to 13, which means that 8 doesn't work, because that would also have to be 5, which repeats. So that must be 6, which is next to 7 to make 13. The last 3 digits are 5, 8, and 9. This 9 first resolves this 8, 9 pair. So none of those are 9 now. This 5, 8 means that must also be 5 or 8 to form 13. Classic 5, 8 pair. The 8 resolves that pretty easily. Now those digits cannot be 7, 8. So to make 15 you can only use 6 and 9, which we can also resolve. You could probably also resolve by, just figuring out what number goes in this cell. And the final digit here would be a 7. That digit is a 5, and we have the heart. Cool, okay. So I like that the solve path pushes you into a heart before guiding you through the rest of the solve. Those digits have to be 8 and 9. Yeah, and those digits have to be 8 and 9 as well, which we can resolve. That's 9, that's 8. And then those digits are 2 and 7. Yep, resolvable. Those digits are 1 and 3, also resolvable by this 3 here. This forms a triple. I think it's a 6, 8, 9 triple. Sweet. And then we have a couple more triples here. Those are 2, 3, and 9. This can be 2 or 3, so that's 9, which resolves this 8, 9 pair. None of those digits are 9 anymore. Those digits are just 2 and 3, which we can also resolve. Those digits are 1, 4, 7. This can't be 1 by this one. This can't be 1 by that one, so 1 goes there. This forms a 4, 7 pair. Oh, in fact, I see that this 8 sees that cell, so that's 6. That's 8. Those have to be 4, 5, 7. That can't be 4, that can't be 7. Those digits are 1 and 6. The 1 down here means that's 6, that's 1. Whoa, 1. Whoa, what did I do? There you go, 1. No idea what I'm doing. Right, so what are those digits? 5, 6, and 8. 6 and 8 can be here, so that's 5. Those digits are 4, 7, 9. This can be 4 or 7, so that's 9. 4, 7 here. We do form a pair. We also get a couple more triples, like those have to be 5, 6, and 8. That can't be 6, that can't be 8. this also forms a triple, which has to be 6, 8, 9. Right, this means now that can't be 8 or 9, that is 6. That resolves this 5, 8, that's 6, that's 8, so 9 goes here. Awesome. This 5 resolves this, yep, yes it does. 7 means that's 4, means that's 5. This is resolved, 4, 7, 4 goes here. Am I reading them wrong? Yeah, it's 4, 7. It's not 4, 7, 4. It's 7, 4, 7. Anyway, those last two digits are 3 and 4, which we can resolve easily to give us 9 minutes and 3 seconds. Awesome. So, early Valentine's Day gift. Yeah, I hope you enjoyed that puzzle. I'll see you next time. Bye bye.